All right, so let's just look at 9.7 part 2. Another way you can solve a system of linear and quadratic equations is algebraically. Maybe it's even a faster method than the previous one we just discussed, which was to solve it through graphing. All right, so when we are going to go ahead and solve these algebraically, we want to do step 1 here, and that is we want to make sure that both of the equations have been solved for y. And our quadratic right here has been solved for y. But we have a little bit of work to do right here in our linear equation to solve it for y. So when solved for y, this one ends up being y equals negative x plus 3. And I can go ahead and bring this one down. Hang on, I'll bring it down in blue because that seems to be what I've been using for the quadratic. So y equals x squared minus 2x minus 3. Okay. So now that we have a system of equations, we can use this idea of substitution. If y equals this and y equals that, well, then we can just let the two of them equal one another. So that means we have this happening. We have x squared minus 2x minus 3 equals, well, they equal each other, negative x plus 3. We want to know when they equal each other. So let's use some algebra and bring everything to one side of the equation. We can even do it in steps. That means that x squared minus x minus 3 equals 3, and I'll subtract the 3 and bring that over to the left-hand side. And that's going to leave me with this quadratic. X squared minus x minus 6 is equal to 0. And we know how to solve, how to factor quadratic trinomials. We're going to look for the factors of negative 6 with a sum of negative 1. So think of two numbers that when you multiply them together, you get negative 6, but when you add them together, you get negative 1. Those two numbers happen to be negative 3 and 2. That allows me to factor this trinomial into x minus 3 and into x plus 2, and of course that's equal to 0. Using the zero product property is going to help us finish this thing off. That means that either x minus 3 must be equal to 0, in which case x equals 3, or x plus 2 has to be equal to 0, in which case x equals negative 2. Well, what we're looking for are the ordered pairs in which these two functions intersect. So we take these x values, x equals 3 and x equals negative 2, and we have to plug them into one of the two originals. I think the linear one is easier to deal with, so I'll just start with that. I have this original equation, x plus y equals 3, and now I'm just going to plug that in. 3 plus y equals 3, and I'm going to solve for y, and that will give me the ordered pair of 3 and 0. And I can use that same linear function, x plus y equals 3, and I can plug in this x value, negative 2 plus y equals 3, and all I have to do is add that 2 over, and I get y equals 5. So that gives me the ordered pair of negative 2 and 5. And I'll go ahead and highlight those. Those are the solutions to this system of linear and quadratics, and we found it algebraically.